Hey there, this is Gaurav. Welcome back with another video. So in this video, we are going to learn about big O notation. Okay. So what I feel, this is the most important topic, especially for those who are from coding world, like developer, or if you want to become a developer, then for you it is the most important topic. No matter what language that you are using, like C, Java, JavaScript, Python, whatever, it is not dependent on language. It is totally a different concept. Okay. And it is there in everywhere in data structure and algorithm. And this is the first topic that you should know before going to learn about data structure and algorithm. So in this video, we are going to learn about big O notation step by step. So let us talk about a situation. Okay. So let's say we have couple of developers in our project, and I have given them a very simple problem statement, and they have to implement that using code. And the interesting thing is, at the end, they all have completed this task and they all came up with their own solution, and they all are giving same output, okay, whatever is desired. So here is the main situation. So we are having a number of solution, right? So if I tell you, you have to find out the best possible solution from all the solution, then how will you do it? Okay, how will you find out the best possible solution from those solution? Like, who is the best developer? Okay, so that is the situation. So how do you find it out? So well, what I think, like quality, yeah, we have to consider quality while checking this, definitely. But again, I am having one question. What do you mean by quality? What that quality term exactly means over here? Like faster, or your code will take less space, memory space? Well, we will understand the concept of quality in this video as well. Okay, and big O notation is something which will help you in that case. If you have a number of solution, then big O notation will help you to find out the best possible solution in terms of quality. Yeah, it's really big in significance. So I'm going to talk about that problem statement and those solution and coming up with best possible solution in this video just within a few seconds. But the main motto of this video is not about knowing or understanding or learning the concept. It's all about implementing the concept. So whatever code you will write, you have to implement the concept, okay, like the big O notation, so that you will have a best possible solution. So without wasting any further time, let's jump right in. Well, so let us look at the problem statement which I have given to those developer. Okay, so it says, given a number a and limit n. So these two are my input, a and limit n. Find the sum of multiple of a up to n. So let me show you one example you can understand. So here we have two input. Let's say a as 4, n as 23. So what are the multiples of a? So we have 4, then 4 into 2, 8, 4 into 3, 12. In this way, we have 4, 8, 12, 16, 20. In this way, okay. So we should go up to 23. We cannot go beyond that, okay. So that's why we are taking up to 20, because after that we have 24, which is more than 23. So what is the sum? The sum is 60, like 4 plus 8 plus 12 plus 16 plus 20. So that's what my output. So let us look at another example. Okay, so here I am giving you a as 2 and limit n as 11. So what are the multiples of 2? It is 2, 4, 6, 8, 10 in this way. Okay, but we can go up to 11. We cannot go after this. So after this we have something like 12, so which is not possible. So what is the sum? 2 plus 4 plus 6 plus 8 plus 10, 30. So I'll be giving you a and n. So you have to find out the sum of multiple of a up to n. Okay, so that is a problem statement which I have given to all those developers. But before that, if you want to implement this from your side, just pause the video and try it out from your side. So here I'll not talk about all those developers. Rather, I'll talk about, let's say, two developers we have, like John and Thomas. Okay, so I'll provide this problem statement to those, and let's say they will come up with their own solution. Let's say solution A and solution B. So we have to find out which one is better. Okay, so that's what we are going to do in this video. So now let me show you the solution A and solution B, like what John has implemented and what Thomas has implemented. Now it will be your job to find out which one is better. So let's see that. So here I am not Gaurav. Just for a few moments, consider that I am John. Now here I am going to show you solution A that has been implemented by John. So the programming language that I'll be using, JavaScript. So let us open JS bin for editor. So I'll be using JS bin for JavaScript editor, that is IDE. So let me choose JavaScript, not HTML, then console. I don't want output. Yeah, that's it. So here is my problem statement, you can see. Okay, so I'm going to show you the implementation has been done by John. So now let me take a function. Let's say function named find sum A, so that you can understand this one is for solution A. So this will be taking two arguments, as I can see as my input. One is A, another one is N. Okay, now this is something that will going to return sum. Now as I am returning sum, so I have to declare it as a variable. Okay, so I will declare it as let, because my sum will keep on changing its value, and let us initialize it as 0. Okay, now let me call the function inside console. So I'm calling it, and while calling I have to pass the value. So I'm passing 4 and 23. So I should be getting output as 60. Okay, so let me take a for loop over here where we will going to calculate the multiples of A. Okay, and we can keep on summing that value. So let me take a pointer over here. Let's say I. So what is the initial value? So initial value would be A, because I need the multiples of 4, right? Like multiples of A. So initial value would be 4. So then after that, what is the condition? So my limit would be N. I cannot go beyond that. So now this is the important part, how I can increment that I. Okay, so we'll do it just now. Okay, so here is my sum, and I'm going to add up my previous sum with I. So initially we have 4. Okay, so let us do one thing. Let us talk about what are the multiples of 4. Then we have 8, then we have 12, then we have 16, and we have 20. Okay, so initially it should be 4. Now after that loop will end, when the control goes to here, like increment part, it should be 4 into 2, right? So that's mean my next I would be A multiply by something. Okay, now it should be 1, then 2, then 3. This is how it should be increased. So let's put one more pointer over here, and initially this pointer would be, let's say, j equal to 1. Okay, now after that we'll be keep on increasing this pointer. So let us check now. So initially what is the value of j? Initially it is 1. Okay, and then we are adding as 4. So now j is incremented by 1. That means now we have 4 into 2, because j is now 2. Then I became 8, and that's how it will increase. Okay, so let me run it, and let's say what is my output. It should come 60. Let us do that. Yeah, we are getting 60. Now if you want to see what are the multiples that we are getting over here, let us do one thing. Let us just put one console over here, and let us check I. So now if I run it, so you can see how I is increasing, like 4, 8, 12, 16, and 20. So this is the one solution that has been implemented by John, that is called solution A. So now we will see solution B. So let us see that. So here I am going to show you solution B, which has been implemented by Thomas. So consider for a few moments myself as Thomas, not Gaurav. So again, let us take a function. Let's say a function name is find, then sum, and then B. Okay, so that you can understand this is for solution B. Now again, it is taking two arguments. Okay, one is, let's say, A, another one is, let's say, N. So now after that, let us call this function with those input. Okay, then I am passing two argument, that is 4 and 23. All right. Okay, so now let us understand one concept. Okay, so now what are the multiples of 4? 4, then 8, then 12, then 16, then 20. Okay, so can I write this one as like this? So let's say we have 1, then 2, then 3, then 4, in this way. Can I write this one? Okay, so if I have to sum of, then can I write the same way, like if I add just 1 plus 2 plus 3 plus 4 plus 5. Okay, so I can understand if I need to sum this one, this part is fixed. Okay, this is my a, and this part will be the sum of natural number. So my, let's say my final sum would be, it is fixed, a multiplied by my sum. Okay, because I have to find out this one my sum. So here we have to find out the sum of this number, right? So for that we have to find out the this one, like the maximum number. So as you know, the formula for a sum of n natural number, it is n into n plus 1 by 2. Similarly, if let's say for me this 5 is m, if somehow we can find it out this maximum value in this number as m, then my formula would be m into m plus 1 then by 2. This would be my formula. Now again, how do I find it out m? That's the main question. Like how can I find it out this 5 value? Okay, so here m can be easily calculated by doing n by a. Okay, so if I do 23 by 4, that we will be having 5 point something. So we have to take our 2 decimal part, and that's why we have to use math dot floor. By doing it, we will get 5. Okay, so let's say if this limit is 26, then 26 by 4 will get 6 point something. That means up to 6. Okay, because 4 into 6, 24. This is the last term that we can take. Okay, so this is how we can find out m. Okay, so now let us declare those variables. So first we have m, then we have sum, then we have final sum. We don't have to initialize it as 0 because we're not changing this value. Okay, so now let's return my final sum. That's it. So now let us do one thing. Let's run it. Let's see what we are getting. We're getting 60. Okay, so now if we change it with 2 and 11, let's see whether we are getting 30 or not. Yeah, so we are getting 30. So this is one more solution that I have shown you, which has been done by Thomas. So now let us see which one is better, solution A or solution B. So now you can see we have both the solution, like solution A and solution B over here. Okay, and we will find out which one is better. So let us do one thing. Let us find out how much time solution A and solution B they are taking individually. Okay, and that is why we have two parameters. You can see T1 and T2. We are just checking the time before we are calling the function, and we are checking the time after calling the function, and we are just trying to find out the difference, time difference in second. And the same thing that we are doing over here as well for solution B. Okay, so let us run now. Okay, so I can see I'm not getting major difference over here. So this is the time which has been taken by solution A, and this one is by B. But I cannot find major difference over here, but I can understand one thing, that solution A is taking more time. Okay, so let us clear it again, and let us do one thing. Let us increase the limit. Okay, I'll be adding 30 over here and 30 over here. Okay, let's look at it, whether we are getting any major difference in between both the solution. So now here I can see it is taking more time. Okay, but still I cannot find any major difference. Let us do one thing. Let us clear it. Let us add one more 0 over here. Okay, all right, let us run now. Okay, so now I can see this one is taking more time than this one. Okay, because 0.02 second in computer science is huge. Okay, compared to 0.00001 second. So one thing I can say, solution B is far more better than solution A. If I talk about the time it is taking, so that's where we have the concept of time complexity. It means time taken by your code as input grows. So here my limit is basically growing. Okay, so initially for lower limit I'm not getting any major difference, but as I'm increasing this limit, okay, I'm getting some difference. So that is one factor if we talk about quality, okay, that is time complexity. So even if you're working with small data set, try to maintain the quality of code, okay. Now it is not a good way of comparing both the code using time complexity. By doing this, it's not a good way. So there are some better way of doing it, and that's what called big O notation. So big O notation will help you to finding out time complexity. So let us talk about code quality. Like, what do you mean by quality? What are the factors that you have to consider while finding best solution? So the one factor that I have already shown you with an example called time complexity. So it is about how the runtime of code or an algorithm grows as the inputs grow. Okay, so we have seen if you are increasing the limit, that is n, then the time that our code is taking, it is also increasing. So in time complexity, we will see if my input is growing, then the runtime of my code is also growing and it is following some kind of nature. We will talk about it later. Or in other way, you can say it out in this way. It is all about the amount of time it is taking by our algorithm to execute it completely. And the next factor is called space complexity. It is an amount of memory used by the algorithm to execute it completely. So here there is a concept called auxiliary space that you have to understand, which is very important. See, if my input is growing, let's say if my n is growing, definitely my code will take more space, right? So auxiliary space is nothing but an extra space which is taken by our algorithm. Okay, it is not including the space taken by the inputs. So we will talk about it later. So these two are the main factors. And big O notation is a mathematical notation. It is a way to find out the quality of the code in terms of time and space complexity. So that's all for part 1. So this video that I have created, this is just an introduction in order to start big O notation. In the next part, we will finally start big O notation and we will see how we can approach any algorithm and we will find out time complexity and space complexity using big O notation. And that's how we will compare and we will get our best possible solution. We will also see what kind of possible natures that can be there for an algorithm. We will also see like how my solution B is a better solution over solution A if I talk about time complexity, and that's what we will find out from big O notation. So I hope you understood about why we need big O notation. What do you mean by quality of code? What are the factors? Those are there. Okay. Thanks for watching this video. If you have any doubt, any queries in this video, please let me know by giving a comment in the comment section. For more videos, you can follow my channel. For now, take care. Tata. Bye bye.